Hello, welcome to our project. We are representing you to our autonomous paper stapler. This is our project team. This is our product's proposal. The product can staple 10,000 A4 papers per minute. You can see our proposal in there. This is our objective diagram. In the objective diagram, stapling of papers separated two parts. On minute use, stapling 10,000 A4 per minute, stapling 20 A4 at the same time. On the stapling 10,000 A4 per minute, separating two parts, silent working and fast paper change. And the fast paper change to be followed by does not misalign the papers. Stapling 20 A4 at the same time separated two parts does not harm the papers to be strong. This is our function tree. Staple papers separated two parts, fast stapling and staple multiple papers. Fast stapling to be followed by unminute usage, and the unminute usage is followed by autonomous system. The autonomous system separated two parts, motor and software. Stable multiple papers is followed by strong pushing force.
Hello, I'm Furkan Türk. I will continue from this part. This is our black box diagram. We can show them as 12 pieces of paper, staplers, and electricity. After these entries, the component we get at the exit is a dozen punched papers. When we look at the function tree, 12 pieces of paper are placed in the paper bin at the beginning. Then the papers are sent to the organizer by means of electricity. After the papers are arranged, they are stapled, and these stapled papers are sent to the empty bin. After this part is over, let's talk about QFT. While we wrote the customer requirements on the left in QFT, we talk about our technical requirements on the top. Those who were compliant with these requirements were given a high score, while those who were less compliant were given a lower score. Completely incompatible were left blank. On the right, it is shown how well the 4 different stapler manufacturers can meet customer demands, while at the bottom it is shown how well the manufacturers can meet the requirements we have chosen. At the top, relationship between the requirements, which is called the roof, is shown. Let's talk about morphological chart section. In the morphological chart section, you can see the ideas we produced for transfer, stapling, warning, aligning topics that we wrote in the attribute section. Our design is the one marked with a circle. The one marked with a triangle is our second design. Thank you for listening for me.
This is our decision matrix. We separated the criteria as standard stapler, alternative as standard stapler, clear staplers, and tabletop units. This is our criteria: easy to use, easy aligning, fast, compulsory electricity, compulsory controller, quiet operation, portability, be affordable. This is our first decision. We use conveyor belt, stapling is used, slider is used, and light is used. Sorry, this is our second decision. Thank you for listening to me.
This is our SolidWorks drawing. The papers desired to be stopped are placed in this unit. This unit desired in paper size and includes tolerance values. Here, with the help of wheels, the papers are transferred row by row, the stapler unit, by passing through a small cap. Staplers are controlled by shafts and motor. Then, with the help of the pistons here, the papers are aligned before they are stapled. Then they are stapled with the piston staple mechanism here. This is a box in which the staples are located. After this process, the stapled papers are returned their original place with this pump. It is then taken out these wheels. Thank you for listening to us.